We're gonna start talking about logarithms today. Let's first start with some powers, right? So here I have 2 to the power of 1. What would that equal to? 2. All right. Now, if we just pause here for a minute, what do I call this number 1? That's the exponent. And what is this number here? That's the base, right? So any power has a base and an exponent, right? Okay, so 2 to the 1 is equal to 2. What about 2 squared? It's 4. What about 2 cubed? It's 8. Okay, so now look at what happened here. In going from an exponent of 2 to 3, right, my value jumped from 4 all the way to 8, right? From going 2 to 3, I went from 4 to 8. I skipped 5, 6, 7, right? So what if, though, I wanted to get a 6? What if I wanted to raise 2 to an exponent and get a 6, right? How could I do that? So basically, what exponent of 2, right? So here's the question I'm asking now. What exponent of 2 will give me a result of 6? In other words, 2 to the power of what will give me 6? So what do you think? If 2 squared is 4 and 2 cubed is 8, what do you think that number looks like? What do you think that number looks like? Is it less than 2, greater than 2? Greater than 3, less than 3?
2.5.
Something like 2.5, right? What is 2 to the power of 2.5? Anybody with a calculator on them? What's 2 to the power of 2.5?
5.6.
It's 5.6, so it's not even that. So you could now try another number. Maybe it's 2.6, maybe it's 2.8. Or, you could sit there and do this until you're blue in the face, or we could do it differently. So to answer this question, what we need is a logarithm. All right? So what is it that we're looking for right now? We're looking for the what? The exponent of 2. So I'm looking for 2 to the power of something that will give me a 6. So what I'm looking for is that exponent of 2 that will give me a 6, right? And I just said that to answer the question, we need something that's called a logarithm, okay? So if I ask you the same question in another way, then a logarithm answers the question of what exponent of a given base will result in a specific value. So a logarithm, all right, tells you what exponent of a given base will give you a certain value. So what is a logarithm then? It gives you what? The exponent, right? So if you're walking down the street and somebody taps you on the shoulder and asks you, what is a logarithm? What do you say? It's an exponent, right? So what is a logarithm? It's an exponent, okay? That's all a logarithm is. It's an exponent. Okay, so now I can write my question like this, 2 to the box equals 6, but that's so elementary school, right? Or I could write it in another way. I could say log, okay, what's that number 2 called? That's the base, so log base 2 of 6 is equal to what? That's the exponent, okay? So I can ask the same question in 2 ways. I could go elementary school style and I say 2 to the what equals 6. Or I could say, or I could say log base 2 of 6. And I'm asking the same question. So if I were walking down the street and I saw this log base 2 of 6 written on a billboard, log base 2 of 6, I go, oh, 2 to the power of what gives you 6? That's what that means. 2 to the power of what gives you 6? Yes. Okay, so if you're walking down the street then, right, and you see something like this, log base 3 of 9, what is it asking you? 3 to the power of what gives you 9, she's saying. Is she right? Yeah. She's totally right. If I saw something like this, what is that asking me? 2 to the power of what gives you 16. Awesome. Okay, good. So now we totally know what a logarithm is. Okay, a logarithm is an exponent. All right, so here is, like the official definition of a logarithm, right? And it says, if I have log base b of x equal to y, remember, this is the base and this is the exponent, right? And I can rewrite it as the base to the power of the exponent is equal to x. That's called the argument of the logarithm, okay? All right, so one more time, I really want to stress this. The answer to a logarithm is always a what? An exponent. Awesome. Okay, once you have that straight, this chapter will just be simple. All right, so here, we're just going to get used to a couple of things as far as notation is concerned. We're going to write each of these in exponential form. You're given the logarithmic form, you're going to convert it to exponential form. So the first thing you want to do is identify the exponent. In here, log base 3 of 9 is equal to 2. Which one is the exponent?
2.
The 2 is the exponent. Now, every exponent has a base. Where's the base?
3.
The 3 is the base. And when you think of it that way, then you know exactly where everything is going to go, right? So the base to the power of the exponent equals what? 9. You see that? All right. So what about this one? Tell me where the base is. 10. Where's the exponent? 10 to the power of negative 2 equals what? 1 over 100. Isn't that fun? Okay. So who's going to tell me how the next one works? 3 to the power of 6 will be 729. Okay? All right. Now we have the equations written in exponential form, and we want to convert it to logarithmic form. All right, so let's do this one. Again, this is the base, this is the exponent, right? So the way it works is log base what? Base 5 of what? 125 is equal to the exponent always. Okay? All right. So here, log base what? 27 of 3 equals 1/3, the exponent. All right, so go ahead and do the next one then. I'll give you a second to do the next one. I'll pause this. It's log base 6 of 1 over 216 equals negative 3. Any questions? Okay, so these are ones that we need to evaluate. All right, evaluate means just find a numerical answer to the problem, okay? We're not going to use our calculators. In fact, your quiz is going to have 2 parts. Some without. These are going to be on the part without the calculator, some with, okay? Now, with exponents, I get it. Numbers tend to go up very, very quickly. I try as much as I can exponentially. Look at that one. So I try to keep the numbers manageable as much as I can on the test or the quiz, okay? And I do use some bigger numbers in the notes because, we could use each other's brains to figure things out. Okay, so you're walking down the street and you see this on a billboard. What is it asking you?
What?
Yeah.
The power of what is equals 243.
That's it. Once you see it that way, you have no idea how simple these become, okay? So the question is, 3 to the power of what is 243? You either know this because you've done it for the past 30 years of your life, or less. Or at this point, we could still guess and check on the calculator. So what do you think? What exponent of 3 will give you 243? 3 to the power of 7? 3 to the power of 5, right. So the answer is just 5. The answer is not...
Oh, you don't put the whole thing in.
Right. So the answer is not 3 to the power of 5. Remember, the answer to a logarithm is a what? An exponent. You just need the exponent. Okay? All right, what about the next one? We're looking for 3 to the power of what? That gives you 81. What do you think? I have a 3, I have a 9, I have a 4. I need somebody of 4. 4,
Yeah, 4.
right? 3 to the power. Okay, so what if you absolutely don't know? What do? Well, you take your 81 and you do your factor tree, right? This is 9 times 9. This is 3, 3, 3, 3. So what's 81 made of? 81 is made up of 3 to the power of 4. Okay, that's another way for you to figure it out. All right. Okay, what about the next one? What is the next one asking me? It's, what's the base? 1/8 to what power will give me 512? Okay, so there are a couple of things at play here. The most important thing you need to look at is that I'm going from a fraction to a whole number. So you need a negative exponent. Okay, awesome. Going between a fraction and a whole number just makes the exponent negative. So the way I would do it, the way Miss Malikian, would do it is this. I ignore the fraction business for a second. I just look at the 8 and the 512. And in my mind, I ask myself, okay, 8 to the power of what will give me 512? So what do you guys think? 8 to the power of 3 will give you 512. But because it's a fraction to a whole number, then I say -3. Okay, so the answer is -3. Yeah.
Like I get that.
The next one, what am I being asked? 1/6 to the power of what gives me 1/216. Now, is this problem the same as before where I'm going between a whole number and a fraction? No, it's fraction. So am I going to have positive or negatives for my positives, right? When they stay in the same form, it's positive. All right, so what do you guys think? 6 to the, okay, you can totally do the factor 3, okay? But it's 3, 6 to the power of 3. So the answer here is 3, okay? Now, once we recognize that a logarithm, the only thing a logarithm is an exponent, we can then go and start exploring, right? So let's start exploring. If we explore the properties of 1 and 0, so since we're talking about exponents, you know that some special things happen when you have an exponent of 1 and an exponent of 0, right? So any number raised to the power of 1 is what? Is itself. And any number raised to the power of 0 is what? 1. Okay? That's important. This is where this stuff counts. All right. So let's do a little bit of exploring here. So what's 2 to the 0? 1. If I were to write that as a logarithm, what would it look like? This is the base, right? So log base 2, and this is the exponent. So log base 2 of 1 is equal to 0, right? Okay, so let's move on here. What's 3 to the 0? What's 4 to the 0? What's b to the 0? 1. What's table to the 0? 1. All right, so now, if I were to write the second one, 3 to the power of 0 equals 1 as a logarithm, what would that look like? Log base 3 of 1 is equal to 0. All right, so what you're going to do, I'm going to give you 5 seconds, is you're going to write in the next two as logarithms. Okay, so does everybody have something that looks like this? Log base 4 of 1 is 0 and log base b of 1 is 0. Okay, now I need somebody to raise your hand. Tell me, what patterns do you see here? What conjectures can we make? What patterns are we seeing? Yeah.
The base
Uh-huh.
is spelled 1 because and the 1 and the 0 always stay the same because
Okay.
the power of 0 holds 1.
Okay, so let's rephrase that. Can anybody rephrase that? Yes, Mariah.
Regardless of the base,
Mhm.
it's always going to be your always going to be.
Okay, so regardless of the base, regardless of the base, what's log of 1 always? 0. Because no matter what the base is, if the exponent is 0, you get 1. So regardless of the base, log of 1 is always 0. And guess what? Guess what you guys just did? You just came up with a property of a logarithm. This log base b of 1 equals 0 is a bona fide property of logarithms. And you just came up with it because it's that much of common sense. Okay? All right.
1 because 1 to the power of anything is 1.
Okay, so let's do exponent of 1 now. So what's 2 to the 1? 2. So if I were to write that as a logarithm, what would it be? Log base
2 equals 1.
of 2 equals 1, right? Okay, 3 to the power of 1 is what? 3. Okay, so everybody together, how does the log look? Log base, right? So what's 4 to the 1? Okay, what about b to the 1? Ladies, what about b to the 1? B to the 1 is b. What does the logarithm look like? Log base b of b equals 1. Okay, so tell me what the pattern is. Tell me what the pattern is. Yeah, it's like, yes, I see the hand motions, but in words, in English.
So I forgot what the name of the number is, but like the law, like the base
Uh-huh.
and the number right
The-
after the base.
Argument.
The base and the argument are always the same.
Uh-huh.
When the exponent is 1.
Okay, so, and then if you say the converse of that, so if the base and the argument are always the same, right? What's the logarithm equal to? 1. All right? So when the base and the argument are the same, the logarithm is always 1. So log b of b is always equal to 1 because any base to the power of 1 is the same number. And here, any base to the power of 0 is 1. All right? You cannot allow yourself to forget those. If you're walking down the hallway and somebody taps you on the shoulder and says, hey, what's log of 1? What do you immediately say? What's log of 1? 0. What's log of 1? One more time. What's log of 1?
0.
Okay. What's log b of b?
1.
Right? It's got to be very, very quick. All right? So quick that if it's like 3:30 in the morning and you're fast asleep and your cell phone rings and you pick it up and it's me and I ask you, what's log of 1? What are you going to say? 0. It's that quick. All right? Okay. So,